Alright, so today we're going to be doing lesson 3, section 6, which is solving polynomial equations. Okay, solving polynomial equations. Now, something about this lesson is we're going to be reviewing a lot of the concepts from chapter 2. However, we're going to be adding a little more depth to them. So it's really important that you're paying attention here because this can be a little bit tedious of a process. And you want to make sure you know where all the numbers that I'm getting are coming from. And we're only going to be building off of this more and more as the year goes on. So really make sure you're paying attention while I go through. We're only doing one lesson today, so you guys should be good. So let's get started.
Oh my God, I'm sorry.
I thought that was one of my virtual kids. Okay, so solving polynomial equations. Step 1 is to move all terms to one side and set the polynomial equation equal to 0. Step 2 is to factor the polynomial completely. And step 3 is to set each factor equal to 0 and solve for each x value. So after rewriting the cubes, either factor or use the quadratic formula. Yes. Thank you for that. I could see it on my screen, but not for you guys. So yeah, the fill-ins are factor or use the quadratic formula. Now, you can also sometimes, I wish there was a third line, complete the square. So you can add that in, complete the square. So completing the square also comes up in this topic as well. You're going to see we complete the square sometimes too. So those are the main 3 things that we do when this occurs. So you're not going to fill anything in here. This is just telling you how the signs change. And we'll use this formula as we go through the lesson. Later on in the lesson. Yes?
Wait, it says
Quad formula? Like quadratic formula? It's just an abbreviation for it. Anything else? Any other questions? Alright. So for the first example, the first thing we're going to do is we're going to move the 3x to the other side. So go ahead and subtract that 3x to the other side. Now when you do that, you're going to end up with 2x to the third minus 5x squared minus 3x is equal to 0. And your goal now is to see if we can factor something out as a GCF. So do you guys see anything that we could factor out? Yes, good. We can factor out an x. So we're going to factor an x out of each term. And this is going to become 2x squared minus 5x minus 3 equals 0. And now we're going to see if we can factor the trinomial that's left on the inside of the parentheses here. So we can't particularly factor this, but we can use the AC method. You guys remember the AC method where we multiply here, the 2 and the 3? And this would become x times x squared minus 5x minus 6 equals 0. And then we can factor this into 2 binomials. So what are the 2 binomials? What do we factor that into? Negative 6. What are some factors in negative 6 that add up to negative 5? Negative 6 times positive 1. Very good. So negative 6 and positive 1 because they add up to a negative 5. Now if you remember back to the AC method, we multiplied by the 2, so now we have to counter that out by doing what down here? Good, dividing by the 2. So if it divides, you divide it, becomes 3. And if it doesn't divide or reduce, you bring the 2 back in front of the x, like that. And that's what you end up with. Now from here, this is where the steps are new. We factored it completely, but now we want to find the zeros. So the zero product property says if we have 3 products, or x amount of products, however many products, n products, we can set each of those products equal to 0. So we can set each of these equal to 0. So that's going to be x equals 0, that's going to be x minus 3 equals 0, and that's going to be 2x plus 1 equals 0. And then we can solve it. So over here we don't have to solve. Here we add 3 to both sides to solve that. And we get x equals 3. And over here, I subtract 1 on both sides, which gives me 2x equals -1. And then I divide both sides by 2, which gives me my final answer of x equals -1/2. So these right here are our 3 solutions. Can anybody tell me what these actually represent on the graph? They represent where we hit the what axis?
X.
Good, the x-axis. So in this particular in this particular cubic polynomial, this is where we hit the x-axis, okay? So does anybody have any questions about this part so far? All right, let's try another one. So the next one that we're looking at is the U-try problem. First thing we're going to do is we're going to get that 9x to the other side. So I subtract 9x on both sides, which leaves me with 3x to the third, 3x cubed, minus 6x squared, minus 9x equals 0. So that's where I'm at right here. Now we look for always a GCF first. So do we have a GCF here? A greatest common factor?
3x.
Good, 3x, very good. So I'm going to factor out a 3x out of each term. That's going to become x squared minus 2x minus 3, like that. And then from here, we should be able to factor that trinomial. Hopefully we can factor it and not have to use quadratic formula or completing the square. So I'm going to bring down the 3x, and I'm going to write this as the product of 2 binomials, x here and x here. And then we're looking for factors of -3 that add up to a -2. What do you think?
-3 and +1.
Very good, -3 and +1. We didn't use the AC method, so we don't have to divide to counteract anything. We're at this stage where we have 3 products, in this case equal to 0, so we can set each product equal to 0. And then you're just going to solve for x for each example here, each equation. So this becomes 0, this becomes 3, and this becomes -1. So any questions on that? Those are our 3 zeros. And to clarify, if you plug any of these in back into your equation, you're going to get a true statement. This is going to equal 0. So that's what that means, what the zeros are. They give you where y is equal to 0. So that's that. Any questions? All right. Now we're going to try some GCF and completing the square problems. So these are going to require us to find a GCF and then also complete the square. So the first thing you always want to do is get it to one side of the equation. Well, not always, but in most cases you will. So I'm going to subtract 6x cubed on both sides. Now my goal is to write this in standard form. So I'm going to rearrange and put the minus 6x cubed in the middle of these two, okay? Like that. So I just subtracted it over, but I arranged it so that it's in standard form. Now my goal is to look for a GCF. What do you guys think the GCF is here?
3x.
Good, 3x squared. So I'm going to factor out or divide everything by a 3x squared, which is going to leave me with x squared minus 2x plus 4. Like that. And now from here, my goal is to factor this trinomial. Now, I don't know about you guys, but I can't think of anything that multiplies to give me positive 4, but adds up to a -2. What do you think? No, there's not anything. So this is why we can't factor this the normal way. So your choice here is either to use the quadratic formula or complete the square. But I'm going to complete the square in this case because it's a little easier. But I just want to let you know that you could have also used quadratic formula. So I'm going to remind you guys how to complete the square. We're going to kind of do it in a more condensed way because we have it within another problem. So first thing you're going to do is you're going to rewrite this equation, but you're going to leave space in front of the 4 and after the 4, kind of like this. So all I did was I just made space before and after the 4. I didn't change anything. I didn't add anything extra. I just made space before and after the 4. Because we're going to create our own C term that's going to help us factor this thing. Anybody remember how we create that C term? We take half of this term and then do what with it? Anybody remember? No, that's okay. So you take half of your B term and square it. So what's half of -2? Good, -1. And then -1 to the second power is +1. You're going to add +1 here. Okay? Now from here, we added a +1. Can we just go around adding numbers to equations? We have to balance it out, right? So if I add 1, I have to do what to cancel that out? Subtract 1. So I have to add 1 and subtract 1. So what we did was we made our equation more workable, but we didn't actually change what it is. I could simplify this and I would get just +4. Everybody see that? So I didn't change what my equation actually is. I just added 1 and took it back away, which is totally fine. Didn't change anything. So then we're going to kind of look at this as it's grouped together, okay? We're going to try to factor this portion of it. And then we're going to try to combine this portion of it. Okay, it's just like a tool. So I can factor what's in the orange because we made it factorable, right? So what is x squared minus 2x plus 1 factor into? Ideas? Good, -1 and -1. Whoever said that, good job. So this factors into -1 and -1 because factors of +1 that add up to -2 are -1 and -1. They multiply to +1 but add up to -2. Now over here we're just going to combine these, which becomes 3. So that's this portion right here. And then we just bring down the, I need my pen, not my highlighter, equals 0. So that's where I'm at right now with the problem. All right? Now, how can I rewrite the product of two identical binomials in math? Good, with the second power. I can rewrite it to the second power. And now from here, we have the product of two things. We have the product of 3x squared and then all of this other stuff. Those are two products. They're multiplied together. So the zero product property states that if we have two products, we can set each piece of the product equal to 0. Very good. We can set them each equal to 0. So this becomes 3x squared equals 0. And this becomes x minus 1 squared plus 3 equals 0. And I'm going to solve these as individual equations separately. So I'm going to solve this one over here. So the first thing I'm going to do is divide both sides by 3. And that's going to give me x squared is equal to 0. Now how do we get rid of a square in math? Square root it on both sides, which leaves me with x equals plus or minus 0. Well, positive 0 and negative 0 are the same thing, so we end up with two solutions, which are x equals 0 and x equals 0. So they're two identical solutions. Now, does anybody know why it's important now that we've leveled up kind of in our math ability, why I write the 0 twice? From the last lesson? You guys remember multiplicity that we talked about in the last lesson? Multiplicity talks about the number of times a 0 occurs. What's the multiplicity of x equals 0? 2. Which means that on the graph, does this graph actually go through 0? No, it goes to 0 and then it does what? Bounces. Very good. It bounces at 0 because the multiplicity is even. This multiplicity occurs twice. So that's why writing the same 0 twice, even though it seems redundant, tells us a new piece of information. Now over here, I'm also going to solve for x. So I'm going to subtract 3 on both sides, which gives me x minus 1 squared is equal to -3. And then I'm going to take the square root on both sides, which is going to cancel out my second power and leave me with x minus 1 is equal to plus or minus. Now, this is also kind of a throwback thing. What happens when we take the square root of a negative number? What letter do we use to represent that? I. This becomes I radical 3. And then I add because we can't simplify radical 3, obviously. I add 1 to both sides, and I get x equals 1 plus or minus I radical 3, which means I have 2 zeros, I plus, or 1 plus I radical 3, and 1 minus I radical 3. So we have 2 answers there. So these are our zeros. Now let's think back to what we know about quadratics, okay? Or not quadratics, but polynomial functions. We have all of these zeros, but are they all real zeros? No, what are these called? Imaginary zeros. You know, we've been talking about imaginary zeros. We've been saying how many there are. This is what they actually look like when they happen, okay? So that's what an imaginary zero is. Now, imaginary zeros don't necessarily hit the x-axis. Well, they don't hit the x-axis, but they are what we call a critical point. They're where the graph does something weird. It bends, it moves. We have some kind of change in the graph. And this is what we call imaginary zeros. So if you are to look at the graph at these values, you're going to see there's a change occurring. Now, another thing to mention is imaginary solutions always occur in pairs of opposites. So see how they're the same, but they just have a different sign between them? That's always the case for imaginary zeros. So you guys ready for the next set? Okay. So now we're going to do factor by grouping, which we have learned before, but you may have forgotten. So I will refresh your memory on how to do this. So factoring by grouping is where you actually put a dashed line down the middle of your equation and you factor each side separately. So you look at what you can factor out of each side. So what do you guys think I could factor out of the left side of my equation? X squared. And if I factor out an x squared, I'm left with x plus 2, right? And your goal is to factor out something on the other side that's also going to leave me with a binomial of x plus 2. So what can I factor out on the right side of my equation? Very good. I factored it. You guys got the sign right too. -3. And the reason I want to factor out a -3 as opposed to a +3 is because I knew that was going to make my inside of my binomial positive, which matches the other. So then from here, I'm just going to erase my dashed line like this. And now I'm left with this right here, this equation. Now, what do these both have in common? They both have an x plus 2. So I'm able to factor out an x plus 2 here. So this leaves me with x plus 2 times whatever's left, which is x squared minus 3 equals 0. So that's the step I get to here. And then from here, I'm going to set each of these equal to what? 0. Once you get to this stage, that'll help you find your solutions. This gives me x equals -2. And over here, this gives me x squared equals 3. What do I have to do to both sides of this? Square root. That gives me x equals plus or minus the square root of radical 3, or don't say both, the square root of 3, which means my solutions are x equals 3 and x equals radical 3 and x equals negative radical 3. And these right here are our 3 zeros. And it makes sense we have 3 zeros because this is to the 3rd power. So if we have 3 real zeros, the degree is 3, how many imaginary zeros does this equation have? None. It has no imaginary zeros. And that actually works out mathematically as well. So we have any questions so far on this? You guys starting to get the idea here? Cool. All right. So we're going to move on to the next set. All right, so moving on, we're going to do the next example here. So you guys kind of talk me through this. What's the first thing I need to do in order to try to solve this, factor this? Good, I need to subtract the 12 over to the left, and that's going to leave me with 3x squared, or sorry, 3x to the 3rd cubed, plus 12x squared minus 3x minus 12 equals 0. Now my next thing is to find the GCF. What's my GCF here? 3, so I can factor out a 3. That leaves me with x to the third plus 4x squared minus x minus 4. So all I did was I divided everything by a 3. I just factored out the 3. I just double checked my work and ensure I did that correctly, because anybody can make mistakes. And then my next thing is to see if I can factor this by grouping. So you group it like this, and we see what we can factor out of each side. So what do you think I can factor out of the left side here? Good, x squared times, this will become x plus 4. And then over here, I want to make the other binomial x plus 4 as well. So what should I factor out on the left? Negative 1. Now what can I factor out of both of these? What do these have in common? Good, x plus 4. So I can factor an x plus 4 out, so I'm left with 3 times x squared minus 1 times x plus 4 equals 0. So you don't need that extra set of parentheses anymore. And then what can I do with all of these final products? Yeah, I can set each one equal to 0. So what happens to this first 0? Good, we can eliminate it. Over here I can add 1 to both sides. That gives me x squared is equal to 1. I can take the square root of both sides, which leaves me with x equals plus or minus 1, which means my two solutions are x equals 1 and x equals negative 1. And over here I can subtract 4 on both sides, which leaves me with x equals negative 4. So those are my final solutions on that. Any questions? Okay. So that's part 1. We'll do part 2 after lunch, okay?